Sorry, we're in the middle. All right, so if you're to graph this, it's a parabola shifted right 3, and it's wide. But we're not really graphing that parabola on two fronts. First of all, it's only this part of the parabola. And second, it's meant to show movement. And we need two components for parametric. First, you should show where it was at the original time and the direction it moved. So it should look something like that, the graph. You with me? Okay, we also talked yesterday about eliminating the parameter in trig. How do you eliminate the parameter in trig? I went way too fast here, so I'm going to slow down. You use an identity. So your goal is to get the fact that sine squared plus cosine squared equals 1. We're going to use that. Now, in order to use that, surely we would need sine squared. Based on this fact, surely if x equals 3 plus sine 2 sine t, then sine t equals x minus 3 over 2, and sine squared is x minus 3 squared over, all squared over 2 or over 4. You follow? Stay with me? Yeah. Likewise, I could get a cosine squared from the other one. Cosine squared, based on isolating this cosine squared, is equal to I minus 2, right? Now, if I were to take those, using the fact that sine squared plus cosine squared is 1, and substituting in what sine squared is for this problem, x minus 3 squared over 4, and what cosine squared is, y minus 2 equals 1, then we get an x to y equation. You follow? Now it says, eliminate the parameter. Check. Give domain and range restrictions. Now that requires a little bit of thought and sketch. Now, before I sketch this, I think I'm going to tweak this a little. Wouldn't this be something like, if I add the 2 over, I'd have 3 minus 1/4 of x minus 3 squared if I isolated y? You follow? Yeah. All right then. I know then that this is a parabola changed how? Right? 3 and up 3, opening wide or narrow, and up or down? Down. So my potential parabola looks something like that. Now let's nail down the exact shape based on the restrictions. For the domain restrictions that come as part of your answer, restrictions. Now you might think, well, they didn't say anything about time greater than or equal to 0 here, so we're good to go. X isn't anything. But is it? Sine by nature restricted. Sine has to be between -1 and 1. Okay? So I would argue you're never going to get an x greater than 5 or less than 1. Right? So the restrictions are, here's the thought process for your notes. But because sine is between 1 and -1, 3 plus 2 sine has to be between, maybe I should do this slower. If I double this, then 2 sine has to be between -2 and 2, yeah? And 3 plus 2 sine has to be between 1 and 5. You follow? Now then, that means that your parabola is not ever going to go over there. It's only going to go from, then you can run it. Okay? It's going to be restricted from 1 to 5. It will not be a complete parabola. So x is between 1 and 5. Now you could also restrict the range, and it's good practice What about cosine squared? Cosine squared must be between 0 and 1. Therefore, 2 plus cosine squared must be between 2 and 3. And therefore, y must be between 2 and 3. Now that actually I didn't need to add in because the x restriction is making that y restriction happen. It's going to be between 2 and 3 anyway. That said, you can definitely add it in. What's the two things I'm missing? Yes, question.
So do you want us to do the descriptions for one variable then?
So here's the deal. It's required that you restrict the independent variable in your equation. Sometimes it'll be clear which that is, and sometimes not. So me, I covered my butt by always finding both. You follow? Yes. Great. Yeah, we still haven't located the starting point and the direction of movement. So at time equals 0, where is it? 3, 3. So here it is at time 0. Okay? Now, I think you'll agree that sine gets big and small, big and small. So x will get big and small, big and small. So it'll get bigger, 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 and then smaller, smaller, smaller. So it would start by getting bigger, and then it'll get smaller. So the direction will be back and forth. Now you could show that in a lot of ways, but basically your arrows need to show both directions. It goes back and forth. If you were to graph those two parametric equations in your calculator, you would see this, the little trace going this way. Back and forth, back and forth. And me, when I walk my dog by my neighbor, and the dog behind their fence goes crazy, he's just going back and forth, running it as far. That's what I think. Parametric equations right there. Maybe that dog is going parametric equations back and forth, and the motion of that dog is sine or cosine on x. Yeah? All right, you with me. Move on to the last. Now, actually, let's go here. Say I told you that at a certain instant, time 7, whatever, that dx dt was positive. Which direction is it moving along the curve at that instant? It must be moving to the right, because if x is changing in a positive way, it must be moving right. What if I told you the old Ferris wheel problem, and I told you that at the point negative 12, 12, dy dt is negative. Is it moving clockwise or counterclockwise? Counterclockwise, because at that point, if dy dt is negative, it must be moving down. And if it's moving down, it's moving counterclockwise. Now then, there's a lot of calculus layers to this. That's mostly the focus of tonight's extra practice is calculus on parametric equations. But just by way of introduction, this will get you started. Okay, so you have these parametric equations, and it says find dy dx at t equals 4. Now, students want to eliminate the parameter, because if it's dy dx, then it feels like we should get a yx equation, right? Are you with me? Yeah. Okay, and that's logical enough. But the problem is that they want dy dx as a function of time. They want it at a certain time, not at a certain xy, but at a certain time. And so we're not going to eliminate the parameter because they want dy dx at a certain time. We want dy dx in time components. So how can we do that with timing? dy dt. dy dt over dx dt. That's how you do derivatives in parametric. It's dy dt over dx dt. Now it still gives you the slope of the path, but it's comparing how the x is changing at a certain rate and the y is changing to get that slope. So what is dy dt? 3t squared minus 1 over
Over 1 over, negative 1 over t squared.
negative 1 over t squared,
Minus
3 to the t. We need to evaluate that at t equal 4, right? All right. So the numerator, what is it?
47.
47. And the denominator is what? 1/16 minus 3 to the 4th?
Negative 116.
Negative 1/16. Thank you. You're right. Okay. And there's your slope to whatever it's okay. You follow? Cool. I think you should be on your way on that test. Now we have a lot to catch. Here we go. Okay. Is the oldest thing you have? Oh, actually, the oldest thing you might be 104. Yeah. All right. Let's do 104 questions first. 104, 5.
And 24.
24. 2. 17.
All of it. No, not all of it. I might need help with one.
17. Yes, sir. That's after 104. Yes. In that case, I probably would eliminate. We did. There was sequences. Pretty had a lot of long.
You said it was easy. You definitely did it.
Like a yellow. Did somebody say something like 17?
I said 8.
Okay.
I'm not against 17 being up there, though.
All right. Okay. Here we go.
I appreciate the compliment.
Yeah? Okay. I like
It was kind of
All right. Number 5. 5 is in the book. It's a slope field problem.
I bet that's what fell. Oh, that's what it fell. Guys, if you want to know what fell, I don't know what it was. Oh, I didn't do 2 or 3.
Yeah. That's right. So, the why, so, what are your question is, oh, sorry. What your question is how to do this or how to do it quickly. Either way, I want to communicate well. First, I would look for trends. Wouldn't you agree that when x equals 0, y equals 0, the slopes are 0? So right away, that's quite a few. Okay? Then I would probably work x equal 1 all up and down. When x is 1, actually I'll do this in green. When x is 1, slopes would be 1, 2, 3. Because as x stays the same and y goes from 1, 2, and 3, the slope comes out. 1 times 1, 1 times 2, 1 times 3. You follow? Okay? When x is 2, the slopes are actually, and then we could keep going -1, -2, -3. Then, if I went to x equals 2, the slopes would be, here it would be 2, 1, so 2, then 2, 2, 4, then 2, 3, 6. The idea being, comparatively speaking, the slopes are getting steeper, then -2, -4, -6. And on the 3 side, when x is 3, they'll be even steeper, 3, 6, 9, kind of thing. That's the idea. -3, -6. Same deal on the right. The slopes should be positive in the first and the fourth because signs of x and y are the same, and negative in the second and the fourth. First and third is positive, sorry. Second and fourth is negative. That get you going? Okay, 24, is 24 still a question?
Yes.
Okay. 24. 24 is, yeah, this one was kind of funky. Absolute value inside on the x is a bit of a pickle. Okay, it's just so tempting to say, oh, the absolute value will knock out the negative and boom, I'm good. It just isn't that simple. I wish it were. Would you agree that one of the principles of absolute value is positives are unaffected?
Yes.
So the places where x is positive, that absolute value did absolutely nothing. Another principle is that negatives are affected. They get made like positives. What happens? So these negative x's are not going to do this anymore. They're going to be made positive, and they'll behave just like the positive side. So that absolute value inside causes reflection of the positive side. You could say that f of x is, in a piecewise way, the opposite of normal sine of x when x is less than 0, and normal sine of x when x is greater than or equal to 0. I could do this for a homework, I'd probably just move along, but if this for a test, I'd probably verify, does that work for a point? And I think you'll find it does. Therefore, f prime would be negative cosine of x for x is less than 0, and normal cosine of x for x is greater than 0. Therefore, f prime at negative 5 pi over 6 is negative cosine of 5 pi over 6, which is negative root 3 over 2, which is root 3 over 2, and I believe that makes sense because 5 pi over 6 is here. Positive slope seems coolio. You with me? Yes. All right, 2. Question on 2. Is 2 still a question? Okay. How did it go? Okay. For 2, is your answer off by a factor of 2? Okay, I can explain why. Because I made the exact same error, to be honest with you. It says the brass coating they're putting on is 0.01 centimeters. So if this is x, how much will x change by? 0.02. Why? Because does that coating extend you to the right only? It's extending the right and the left. And so because of that, when you go to do your delta x, it actually is 0.02. It's a coating of 0.01 on each side. And that's why you're off by a factor. So does that clear up your question? I'm happy to do the whole question, if that's okay. So the idea was to estimate the change in volume, or the volume of the layer. That means estimate delta V with dV. dV is the rate at which it's changing times an amount of change in x. In this case, because the volume is a cube, or it's a cube, then V prime is 3x squared. Now, it would matter how big the cube was to how much the layer was, and in this case, the cube is 5 centimeters long. The dx we talked about is a positive only because obviously that layer is increasing the volume only, not decreasing it. But it's 0.02, not 0.01. And therefore, I'm looking at 75 times 0.02, or 1.5. Right? That's cubic centimeters because it's change in volume or volume of the layer. The relative and percent error, that's kind of a misnomer in this case. They probably screwed up. It's not an error problem, really. You didn't measure the side. It's this brass layer thing. So that's it. It's still worth practicing. Relative error is the idea of saying that change, is it big relative to, it's still not much.
Oh, it's stuck on charging, so it won't do anything.
Oh, you have to break in. If it doesn't clear up, I'll
Oh,
take
we're
it.
good. No.
Okay, I'll take it to Mr. Blanc. She does
It's
that.
just 1022, Mike.
Okay, so relative error then would be that error as related to itself, which in this case is 1.5 to 5 cubed. So your relative error should be 1.5 over 125. Or what, 15 over 1,250. You get the idea. Over 2. So it's maybe something like
12.
yeah, 12,000. 12,000, so 0.012, which as a percent then would be 1.2%.
Or not 12.
Okay. All right, 2, check. 17, is anybody in 17? Yes? 17? I'm happy to do it, I just don't want to waste my time. 17? I believe I said no calculator. Okay, so 17. Did you get an effective absolute value graph? I think by far the concept is you can't just mindlessly crank out the volume by, or the area by pretending the absolute value is not there. You have to deal with it. Can't bury your head in the sand. So, oops, this is a +1.
-1 to 2 plus 2, 3.
So yeah, what are the roots are 2 and -1, and it's normally would be opening up and pretty narrow, but now it's got to the below part flipped, right? So from -3 to 1 would have to be broken up into -3 to -1 of the normal or the flip. Did this part get flipped or is it
Wait,
normal?
why is it why is it up and down? Isn't it open up?
It does, but it's absolute value.
Oh god, I thought
Yeah.
we flipped it the other way.
Oh yeah, no, it was opening up.
Yeah, that makes a lot more sense. I don't know why I said that.
Okay, so we're good. This part then is normal f, so it's 6x squared minus x minus 2 for the unnegated version. And then from -1 to 2, or -1 to 1 rather, sorry. -1 to 1, we're talking the opposite, so -6. Or some kind of negative in there, or negative up front. Okay? You on your way from there?
Yeah.
Okay, 18. Is anybody 18? Going? Going? Okay, the fun sheet. Some of this fun sheet probably went great. Some of this you had no idea what was going on.
Oh, I'm sorry.
You missed the going, gone. Nope, I did 17.
I
Why
thought
would I
this
say
was
that?
104.
All right, 18. 18
Oh, wait, no.
is a
Oh,
yes.
the fun sheet became 104. Oh, wait, no, I'm fine. I don't need 18. I'm sorry.
Do you guys need 18?
Do we need 18? Yeah, okay. Why didn't you say so? All right, 18. G.
Make sure it's not anything else but that one is one, Michael. We're gonna be honest, like
Okay.
that's what I thought you said.
One of those things we learned in set 92 is the inverse derivative is 1 over the normal derivative at the inverse point. In this case, you could call it F inverse or G. G is the inverse, so whichever you prefer. Right? In order to evaluate that, we need G at 35. G at 35 would mean 35 is the Y value in the original question. I guess and check, that seems to work with X of 3 maybe?
3 was 3.
3. That means I want f prime, 1 over f prime at 3. That's 1 over 3x squared plus 3 at 3. You get the idea. Okay.
I forgot you would guess in chat.
You could solve it through rational roots theorem. And I love it. Yeah, we don't want to. You saw that, said touch that sugar? Okay. All right. Well, there you go. All right. Here we go. The front sheet. How did your delta epsilons go?
It went well.
Is there one of those you would like to walk through?
3.
3?
Start at 3.
Sure. Let's at least get the delta at 3 and then see if you're...
Yeah, I went to the delta.
Okay, so this would be scratch work, but there you go. I want to work from that until I get to x minus 2, right? So if I, let's see, what shall I do? Shall I multiply out an x, or what, should I get a common denominator? Do you agree I can clear an x out? Actually, let's go here. 3x minus 2x over x is less than epsilon. Cool? Are you with me? Yep. You what? You need to answer a call? Is it from the president or something? If it's an emergency, you may go on the hall. Okay, so x minus 2 is over x less than epsilon. X minus 2 is less than epsilon times the absolute value of x. Are we cool? Am I going too fast? Are you with me? Okay, I'm trying to get to x minus 2, so I was just kind of playing around with the algebra, getting a common denominator.
That's what I screwed up on.
Okay.
So x minus 2.
So then you would say x has to be between, or assume x is between 1 and 3. That means absolute value of x is between 1 and 3. So what is, if I multiply through, then it looks like you're going to use the delta of epsilon.
Wow.
So use delta equals epsilon in your proof. Does that get you rolling with your proof?
Yes.
Okay, I'm happy to go through the proof. Your test is Thursday, and that's going to be on it. So if you want to see
Why
it.
the heck not?
Okay. Okay, so when you go to roll your proof, your first two statements should be let delta equal this and what you're going to prove. So let delta equal epsilon. I will show that if x minus 2, I was looking at the one above it, if x minus 2 is less than delta, then it must follow, or then, if you like, follows that
f of x minus 2 is less than epsilon.
minus 2 or minus L is less than epsilon. Okay? You then
X minus 2 is less than delta.
start with x minus 2 is less than delta, use your delta of epsilon,
You do 1, x, 3.
and then go over and assume. Assume x is between 1 and 3. Then absolute value of x is between 1 and 3. And epsilon is less than the absolute value of epsilon, absolute value of x is less than 3 epsilon.
3
Therefore, by the old trichotomy rule, or A is less than B is less than C idea, if x minus 2 is less than epsilon, and I said epsilon is less than epsilon absolute value of x, it must be the case that x minus 2 is less than epsilon absolute value of x. Now, I would definitely be looking for those absolute values there, because if you had no absolute value on that x and you divided it, you just pretty much sunk the ship. You need to make sure it's positive to verify you're not switching that inequality. So that needs to be, that absolute value is a necessity. It is allowed to call this that. Then here's where you kind of eyeball your scratch work to say, how do I get that backwards to where I want to go? So how would I work backwards to where I want to go? Well, here's where I'm at now. I want to go to,
Make it 3x minus 2x minus 2.
yeah,
Or
call it 3x minus 2 minus 2x. Nobody's going to refute that. That's just algebra. That's the same then as 3x minus
2 over X.
2 over x minus 2. And that is what I was trying to do. Okay? All right, let's go to diffie-q, shall we?
Number 5 was hard. Okay, Mr. Ridley,
5C is a bit of a humdinger. Yes, Mr. Rickman?
Yes, okay. So for two of the group, I went from 3 minus 2 over x minus 2. And then that.
You went from here.
Or I did like the simple proposition. And so I did like 3 minus 2 over x minus 2. Would that work? Or would I just have to like, would I have to like go back?
Yeah, I don't feel like that. I don't see it. Okay. All right. So, A. So let's go step by step. This is a pretty common AP style question. It's missing part B. I don't remember what question B is, but I think it was just like right a tangent line or something. It's something you could do easy. Okay. I didn't waste your time with it. And you'll actually, at this point now, you'll also, I'll just say this in passing, you'll find that if I exclude a part of an AP question, it's not because you can't do it now, it's because you can do it so easily that I don't waste your time. All right? So, sketch a slope field and then pass the particular curve. So, let's go here. I can't tell you how many people lose points because they failed to draw a slope at those points on the axis. They figure they only look at the ones in space. There are points on the axis. You have to have slopes there. Okay? So, the slope is there. And then, depending on how you go, this would be what? 2. Yes?
Yeah.
And 4. And -1 is -2. Okay? At, I think I gave you a little different slope field.
You gave us the lot.
It was to help you. I assure you it was to help you. Okay? The star of the show, I'm going to focus on down here because it's going to be where part B is going to be helped. Okay? I know you're thinking he's so mean to give you so many points. It's a bit of an illustration of a really nebulous idea here I'm coming to. So at -1, you've got a slope of, or sorry, at 0, -1, you got a slope of -1, right? So this is -2, this is -1. And what about at this point? It's -2, yeah? Okay, boom. All right, and then your slopes here, let's see, this would be -2 minus 1, so -3, and -4. This is 2 plus 1, so 1. 4 plus, or 4 minus 1, so 3. What do we got here? 2 minus 2, so 0, right? And what? -4 minus, or sorry, 4 minus 2, so 2.
But not -2.
Okay. You follow? If I ask you to do the point through 1, did I change this 1, 1, or is it 1, 1?
It's 1, 1.
Okay, cool. 1, 1. This slope, I imagine, was positive, is about 3-ish, so it would take you up here. What happens as you get this way? The slopes seem to get flatter and flatter until you hit that way, and it says, hey, go flat. And then what happens as you go this way? It goes up. So your particular solution should have looked like that, or something like that, yeah? Hey, part C we go. All right, now this, you guys, like I said, you guys are smart. You guys are a little smarter than I am, so maybe this won't kook you out as much as it kooked me out when I was in your shoes. It just changed it's bizarre word. Okay? Now, the question says, this differential equation has this as a possible solution. Now, first of all, understand that a differential equation or a slope field is a ton of possibilities. The curve could look like this, or like this, or like this, or like this. On this side, it might be something like this, or this, or this. There's all these crazy possible curves depending on the point it goes through. They're telling you, their assertion is that there is a solution that is linear on top of that slope. Where is it?
That's big.
The slopes are -2. Where do you see slopes of -2? Here's one. Here's one. Besides the concave up, concave down, there's one that's perfectly linear. There is a possibility of a linear solution in that slope. Now then, the slope field is not how you would typically find B. You might get a point for saying, hey, it looks like B is -2. Boom. But you would never get both points because the graph is not a justification. It's conceptual and it helps you understand, but it's not the solution. So collect 2 facts about dy dx. Give me one thing you know about dy dx.
It's 2x plus 1.
dy dx for this problem is 2x plus 1. Okay? But they're also suggesting that this is a solution. If that's the solution, then what's the derivative? Dy dx.
Oh, it's 2, or -6.
Dy dx is -2. Now they're saying, now that to me is what freaked me out. Wait a second. How could y equals -mx plus b or y equals -2x plus b a solution? Because the derivative, that should be -2, not 2x plus y. The derivative for a line is not that complicated. It's just a constant, right? What the heck is going on? Well, what the heck is going on is back substitution. What is, based on this, y equals -2x plus b, what is -2 equal to? -2 is equal to 2x plus y. Okay? Okay. Hang on just a second. I'll come back to this. Now, let's actually go back here. Do you agree if dy dx equals both those things, then those need to equal each other, yeah? Okay, cool. I'm going to go at this slightly differently. All right. Now, it still remains to be seen how can that be the case. But based on their assertion of what y is, what do they say y is? -2x plus b. If you plug in -2x plus b, that would only be the case if b is -2. Wow, that was cool. Now, I guess I kind of went out of order in my argument. I was talking just a second ago about how could it possibly be that the slope is both 2x plus y and -2. Well, if our equation for this problem is y equals -2x minus 2, then isn't -2 equal to y plus 2x? And doesn't it then make sense that the slope is both -2 and y plus 2x? Now that only happens by substituting into itself. But the idea is that differential equations have a lot of possibilities on it. All right, part D. Part D then. I can tell you through vast experience, the biggest mistake people do with part D or these problems is not failure to understand the concept. It's they start thinking that all parts are all related. Okay? I just said there are tons of possible curves. In part A, whatever. Part A, we drew a particular solution here, right? Okay, this they called that, what they call it? They didn't actually give it a name, did they? Okay, that's part A though. Obviously not made for calculus. All right. This though, when they come to this, wow. cannot do calculus like that. It'll take me a board 2 days long. It's ridiculous. Okay, this is a totally different curve. 1, -2 is down here. Don't expect it to look like all these other pieces. It's definitely not that linear case. It's definitely not that first case. It's totally different case. So don't think that that same initial condition applies. It's totally different. All right. So difference equation to the graph. Does the graph of G have a local extreme at the point 1, -2? If so, local min or max? This, by far, is the question. Do you do the first derivative test or the second derivative test? Oh gosh, this homework has a lot of new stuff in it. Yeah, for a reason. First derivative test. Why is the first derivative test 100% no?
You can tell if it's, how to keep up with what you know.
I 100% agree the second derivative test will go great. The first derivative test doesn't depend on a point, it depends on interval, right? Okay, that's great. But in this case, the derivative is a function of both x and y. So you're going to do some crazy two-dimensional sign test and say, no, that's not a thing, okay? If the derivative is a function of x and y, that's, by the way, common calc 3 notation, then use the second derivative test. Because that interval testing is not an issue, it's at a point. So, dy dx at 1, -2, what is it? 0. The second derivative, which we're obviously going to have to find, the second derivative is 2 plus dy dx. Correct me if you disagree, which is 2 plus, what is dy dx?
2x plus y.
2x plus y. Therefore, the second derivative at the test point, 1, -2, is 2 plus 2 minus 2, which is 2. Now, I just proved that at that point, the curve is flat and concave up. Therefore, I must have a min. G has a min at 1, -2 because dy dx equals 0 and the second derivative is positive.
Could you just plug in 0 for the dy dx and then first?
Plug in 0 for dy dx.
Like right after you have the second derivative, where it's just 2 plus dy dx, that's 0.
Oh, yeah, good point. Yeah, absolutely. I didn't even think about that. You're right. Your goal is to find not the actual second derivative, but find it at 1, -2. And at 1, -2, you know that is, so yeah, I guess that makes sense. Okay? How do we do that?
I wrote in the wrong
Okay.
box.
So the takeaway for that is if the derivative depends on x and y, and you want an extrema, you use second derivative, first derivative. All right. Okay, let's go to this bad boy. Did the slope field go okay? When y equals 0, the slopes are 0, so you should have 0 slopes there, yes? And then 1, here the slope would be 1 times 2, so 2, and then 1 times, oh no, 1 times, sorry, 1 times -1, so that's -1 and 2, yeah? Your slope's looking like that?
Yeah.
And then 2 times -1, so -2, -3, and this is what, maybe 2, so 4, and 2, 6, so really steep. What are these? Are these negatives?
No.
Those are
No, they're positives. Okay. Actually, this should be symmetric, shouldn't it? All right, something like that. Okay. Because by symmetry, I mean if those, yeah, because x is squared. So y is the same. Okay. All right. How did part B go? B, your point is 1, 1. Your slope. Look at your work, please. Don't be that person that makes me absolutely bonkers. Do you need to integrate this first to find the tangent line? You don't. You have a point. The slope is the derivative, which you already know. At 1, 1, you're looking at 1 times, what, -2? Did you get a line of y minus 1 equals -2 times x minus 1?
I did.
Okay,
Wait, I got positive.
that's what I said, positive. 2. Okay, so f at 1.1 is approximately 1 plus 2 times 1.1 minus 1, or 1 plus 2 times 0.1, you get 1.2. Okay, cool. Let's talk your solution here. Maybe I should just put the answer in the interest of time. And then go over it if you have questions. Did you get something like y equals e to the x cubed minus x?
Yes.
Okay. If you'd like to see where that comes from, we can do that.
Oh, I got that.
Okay, cool. This guy is B. B is, or the second one is
I haven't listened to it.
C. Do we agree? Okay. This guy is C. This one is A.
C, I got A. No, the derivative of cosine of 0.
It is A.
Yeah.
Okay. A very common, most common error would be people choose B maybe. Okay. But if, remember, you're not trying to graph, you're not trying to, when you go to lay curves on this, you shouldn't be seeing cosine. The solution should be negative sine. Actually, that doesn't look like negative sine.
But the thing is, no, because if you anti-differentiate cosine, you can just get positive sine.
Oh,
The
positive.
derivative of sine.
Really neat. So it is,
What are the other ones? Wait, what are the other three?
it is D,
DBB.
DBB. Get this to me by the end of the day.
How's
And
your day
104.
going, Mr. Richmond?
What?
How's your day going?
Super, duper. How
That's
about you?
good. I'm really tired.
Are you? Do you have a lot to do today?
I had a lot of dudes from last night.
Oh, I'm sorry to hear that.
Got that English thing that I prepared for at 5 in the morning. Didn't go today. Cried a little bit, but honestly, I would have loved to have gone last year. Yeah.
You know, but I would have lived.
Yeah.
I would have.
It was like a lot of cringe.
Oh, that's what I'm sorry. That's for so you don't. Have a good day. Alrighty, I forgot to cross this report.